I welcome you all to the day 2 journey of Atal sponsored Vvit FDP on unlocking innovations with blockchain and generative AI. And I now request faculty Professor Sai Jyoti to present the profile of Mr. Prashanth Kumar Ivaturi, Product Leader, Oracle, India.
Good evening to everyone present here in this virtual session. I hope you all had an enriching experience during yesterday's session. It gives me immense pleasure to welcome you back to day 2 of our faculty development program on unlocking innovation with blockchain and generative AI, organized by Vvit in association with AICTE Training and Learning Academy. Today we are excited to explore the topic advances in LLM and chatbots, a subject that delves into transformative impact of large language models and intelligent conversational agents on technology and society. To guide us through this fascinating session, we have with us our esteemed resource person, Mr. Prashanth Kumar Ivaturi. Prashanth Garu, a warm welcome to you, sir.
Thank you so much. Means a lot. Appreciate you taking the time to welcome me.
Okay, it is my privilege to introduce a truly remarkable professional and a multifaceted individual, Mr. Prashanth Ivaturi, as a seasoned product management leader specializing artificial intelligence, including the cutting edge field of generative AI. Mr. Prashanth has a proven history of building enterprise scale data science features that have propelled Fortune 500 organizations towards success. Currently, as a senior manager at Oracle, he leads AI platform for marketing group, driving innovation and delivering state-of-art AI solutions. His journey spans more than 2 decades across leading technology and consulting firms like Prolifix, Target, and Infosys, always with a focus on creating impactful solutions for clients. Mr. Prasanth's academic credentials are as impressive as his professional accomplishments, holding an MBA in strategy and leadership from the prestigious Indian School of Business and a BTech in chemical engineering from NIT Warangal. But there is more to Mr. Prashanth than his stellar career. He is deeply passionate about innovation, sustainability, and technology's role in shaping a better future. Outside work, he is marathoner, a music enthusiast, an avid traveler, and a food explorer. He remains active on social media too, where you can get to know his exploits better. Thank you. Now I request Mr. Prashanth to take over the session. Prashanth Garu, over to you, sir.
No, thank you so much, Sai Jyoti Garu, for that warm welcome and such kind words. I really appreciate that. And Dr. Kalavati Garu, a big thank you to you as well. Like I said at the beginning, when Priyanka came up to me and she said, "Hey, there is this session there is this entire series of sessions that we're planning at Vvit. Would you like to speak there?" It made me feel really happy because it's a topic which is close to my heart. That's number one. It's passion. Second, it's also an area where I work, so I've been closely associated with that. So I jumped upon that opportunity. But more than that, it has been an absolute pleasure the way Dr. Kalavati Garu has been, in touch with me, assuring me that this is going to be so well. And I attended yesterday's sessions as well. They were very informative. So I'm really pleased, really honored to be here, and I hope that there will be some mutual takeaways. I shouldn't say that this is going to be just a one-sided session where I talk about the LLMs and the chatbots or generative AI or any other thing. But the way I look at this is I intend to share what my journey has been so far in the space of LLMs, chatbots, and what I have learned through my own experience implementing them. And at the same time, what I have learned from several others, and that learning journey will also continue. Right? That's so I deeply I feel privileged to be here amongst such esteemed speakers. And I see Priyanka's picture being flashed on the screen as well. Yesterday, both on the blockchain as well as on the overview of generative AI, they were fantastic. They were fantastic sessions, both of them. I truly loved it. And it has made my job easier for those of you, if you there yesterday as well in the session. If I may say so, Priyanka did a fabulous job of giving an overview of generative AI, what has gone in, what kind of advances have been made in that space, because that becomes more like a feeder into today's topic of LLMs and the chatbots, and half my job is done. So, in a in a in a jovial way, in a joke, as I was telling Priyanka yesterday, that maybe I won't require the entire 3 hours. Maybe I will wrap it up in 30 minutes and be done with it, because she did a fantastic job of explaining and providing a very detailed overview of generative AI. And kudos to the entire team who has actually put this together, because this is not easy. So my deep-hearted thanks to every single person who's leading and organizing these series. It's not an easy task to do. And I do hope that more and more people can, they go away with some really good takeaways from each of these sessions, not just today's session. And the way I typically like to do my presentations is that like I said, I don't intend for this to be more of a one-way conversation. So if there are questions, please feel free to stop me or post them in the chat. I'll be more than happy to respond to them either during the presentation, during the course of the presentation, or if I'm not able to take a look at the chat while I'm presenting, then I'll definitely do so at the end. We can do that, or I will also share my contact details. You may reach out to me after the session as well. So this is not the end of it. So hopefully all of that makes sense, right? So with that, let's get started. It's a fun topic, LLMs and chat GPTs and all of that, and it's been like it's on the rise very, very rapidly. There's a lot of advances that have been made. So let's try to take a step back. For those of you who probably, I don't know what's the mix of the audience here, but I'm assuming that there's a mix of faculty from the computer science department. There's some students, or probably those who are not very proficient with computer science. So computer science or the specific aspects. So I will try to explain some of these in layman terms, right? We can go slightly more deeper. We can peel it like the layers of an onion, but we'll start off with more of the layman languages there. That's one. Second, as Dr. Kalati Garu as well as Saijati Garu introduced, right? I wear a product management hat rather, to be honest. Right? So the lens through which I have looked at large language models or chatbots or generative AI, those have been more from a point of, hey, how do I leverage these in real world situations? So it's more from a practitioner's perspective. So you can think of, so I would probably wear a little more than the engineering hat on these, right? So when we talk about how do you train them, how do you tune them, I do understand the concepts, but at the same time, there is a different lens with which we also see from a implementation perspective, which is more of a product perspective. How do we bring them into the real world? How do we apply them? So what I would also do as we go through understanding the LLMs and chatbots is I will also talk about how can you apply them, right? Where do you want to really apply them, and what are the criteria? How do you pick and think about that, right? That's the most important thing. We can learn as much as we want to, right? The fundamentals, the foundation for all of that. But in the end, what matters the most is how are we able to apply all that we've learned into real world scenarios, right? And that's where the key, the one second, let me start sharing my screen. Do let me know if you're able to see the slideshow.
Yes, sir.
Okay, fantastic. Okay. So yeah,
Yes, sir.
so thank you. So like I said, we'll talk about the application of some of these concepts, right? And what do they really mean, right? So yeah, with that, without further ado, let's jump into the topic, right? So this is the QR code that I was telling a little while ago. You can scan it, you'll get my contact details, and we can get in touch later as well. If you, it's got my email address and phone number, so that if there are questions that you have not asked today, it may be a lot to digest as well. Sometimes when these concepts do come through, there may be quite a lot to digest, right? So take all the time to understand those foundational topics, understand all the fundamentals. When you have a question, you may feel free to reach out to me. This is not the end, right? Okay. This I'll skip this because already Sai Jyoti garu introduced me. But one quick thing that I say is we in the realm that I work with in Oracle. So we belong to the marketing group, and so in an interesting way, it is very, very apt that we're talking about LLMs and generative AI and so on and so forth, because on the creative side, right, the generative AI has been it helps on the creative content creation side of it, generating a lot of content. Marketers become one of those users or the of such technologies, right? It helps them quite a lot, right? The designers and the marketers, they use it. And so the use cases that we get exposed to, there are a lot of use cases which we see in the marketing realm. So pretty apt in that sense. And plus, it's not just the generative AI features that we are building, but there is history and context in terms of building out the predictive AI or the classic AI that people talk about. So there is both sets of features. There are both sets of features that we are building. We are building within the marketing realm, and as I will also take a minute later on when I show one of the slides. We are building out use cases where both predictive and the generative AI features will be applied in the future. So up until now, most of the time it was predictive AI or the classic AI, the machine learning kind of algorithms, all of them were being the focus. Suddenly, when generative AI came into the picture, everybody wanted to say, hey, let's jump onto the bandwagon, let's have generative AI, LLM, and those kinds of use cases built out. But increasingly, as we are learning more and more about these, we are seeing that there will be also a cross section, or there'll be an intersection of both the predictive and the generative AI features. So we'll talk more about that. Right? So that's one piece which I wanted to just call. And quick disclaimer, right? I don't claim that I know everything about LLMs and generative AI. There's so much that's happening in this particular space. It's really hard to keep up with the pace of the changes, the advances that are happening. And if I have to say that until a few years ago, space of AI was limited to a very small set of people who were focusing on data science and the specific area of nuance of artificial intelligence and all of that. But with the advent of ChatGPT, all of that, those barriers have been blown away completely, right? And all of a sudden you see there's so much more growth happening in this particular space. People are coming up with new tools, new technologies, new use cases as well, which it's just really hard to keep up. I mean, I listen to some podcasts from time to time, and every single time that I listen to that podcast about, the recent happenings, there's so much more that has changed. The world has moved on quite a bit. So yeah, I don't claim to be a know-all on that. I'm not the Google of LLMs and generative AI, but I will try to share as much as possible from what I've learned. Okay. Again, I'm not a professor or lecturer, so some of my style of presentation will be different because I come more from a corporate as well as consulting background. You will see elements of me trying to talk about more the practical approach of the practitioner kind of style of things. So there will be a bit of theory, but also a bit of the use cases part of it as well, right? So that's one. And lastly, by the time we would have finished this presentation, there's going to be a lot more from an LLM perspective that would have changed. So that's the pace at which this whole space is moving. All right. Now, with that, quick pause. Question: is there anybody here in the participants, in the audience, or in the panelists who have not used LLMs or the chatbots up until now? Anybody? Raise of hand, or maybe just a verbal response also will do. If there is silence, I'll assume that you have used it. Oh, wow. Okay. I see a couple of hands there. Dr. Irana and Mr. Ashok Kumar, you have not used any kind of LLM or chatbots or anything like that. Okay. Got it. Fantastic. Okay. That is usually surprising because in the all right, Suresh Babu as well. Yeah. Good. So in the recent times, wherever I've asked this question within the office, with our teams, with people outside, and sometimes even with kids, they all have said that we've encountered or we've come across LLMs, we've encountered chatbots, AI bots, all of that, or in some form of generative AI, all of that, right? So it's become so pervasive. It touches so many lives that it's almost very difficult and very hard to find people who have not used it, right? And don't worry, I mean it's not something that you'll be away from for too long, because it's now available. These kinds of technologies are available not just to enterprises or maybe to certain individuals only, but they are also coming onto your phones in every single touch point. And apps like WhatsApp and so on and so forth, on the social media apps also, there's a lot of touch points where the generative AI large language models will be working in the background and you'll interact with them. So if you've not done that, don't worry about it. Like I said, I will also explain it in layman terms. That was just for my understanding if somebody has not done that. Okay, great. Now, question to all of you. What would you like to learn? What would some of your takeaways look like for today's session? Are there any, have you thought about what you want to walk away from this session? Again, if you can probably put it in the chat, or if you want to maybe verbally mention about something, that's fine. If you have come with an open mind, that's also absolutely fine. Then we can cover some of it, because what I want to ensure is as we move along and talk about these, I want to be able to cover pretty much every single aspect that you are interested in learning about it, or at least try to get there, right? Or if I have not been able to cover any specific topic, then in that case, then I will get the right subject matter expert from our team, or maybe from my own network, and tell you that we will get back to you maybe in a few days' time, so that we address each of those queries. But the intent is to be able to try to cover as much as possible. Okay, I see one question in the chat there. How do we create an LLM for our institution? Okay, fair enough. So, sir, you're talking about a foundational model, or are you talking about using a foundational model, building an LLM on top of it? I assume it's the latter. Either way, we can talk about that. We can do that. Right. All right. Any other expectations from this session? If not, okay, let's jump into the so today. So we'll cover a few different things. Like I mentioned, we'll go from the very basics of what LLMs are, what chatbots are. Why do we see strategic value in these kinds of technologies? They're generating content, and by generating content, why do we feel that the LLMs are actually able to drive so much value? And I will show you some statistics as well. Companies are asking, or pretty much every single company on the planet right now, they're asking their teams to invest in features around LLMs and all of that. Yesterday as well, when Priyanka talked about Gen AI, there were some statistics that showed that how that numbers are moving, right? It's in fact, from the time that generative AI landscape came up, from then to now, a lot of the computational costs are coming down. It's becoming a lot more easier to access. There's a lot of development in that space. So why do companies see that strategic value there, right? We'll talk about that. Underneath, how do these LLMs actually work? What kind of, what do we really require there? We'll look at some real world applications, some recent advancements, like I mentioned earlier, right? Some tools and platforms for using the LLMs. And lastly, sorry, not lastly, the challenges, ethical considerations. Typically, we have to talk about it in a holistic way, about what are the different kinds of challenges. Are there any kind of challenging circumstances there? And finally, what are the future of these LLMs and bots? Which way are we headed? Right? So we'd like to look at it holistically to say, how did we arrive here? What is the what kind of considerations? What kind of environment are we working in? And then where do we land? Right? Saijati ma'am, how LLMs are trained on massive data sets using billions of parameters. Okay, sure. All right. We'll cover that. So when we talk about how do LLMs work, we'll touch upon the training aspect also. I'm going to talk in a little brief about that particular piece, but if time permits, we can go maybe into some additional detail as well there. All right, so I already asked this question, so we'll skip this. We're not reflecting on interacting with the chatbot and what we like in terms of conversing, but I'd like to just think about it, right? Those of you who have interacted with the chat GPTs and all of that, have you felt that there was some sort of magic there about, when you asked a question, you probably get a very articulated answer, but still it does not give you the feeling that, hey, it is that kind of, a Google which will give you the right response, right? While there is some magic behind the scenes, it's not completely magic. So there is something more to be desired in all of that. Has anybody felt that? Or have you people felt that, hey, this is absolute magic? What were your thoughts? Did you get the question? So I'm trying to see if how many of you felt that when you asked a question of these LLMs or the chatbots on these LLMs, did you feel that there was magic? Was it like, hey, wow, this is great. I'm getting some kind of a response which I didn't even think about, right? I mean, until now, Google search was what I was looking at, but now all of a sudden I see that there's. I see. Okay, Sudhakishore, Mr. Sudhakishore, I see that. Yep. Dr. Jayabharati, yeah, okay, great, okay, yeah. So my personal feeling, it's been a mixed reaction. Okay, about a year and a half to, or maybe 2 years ago, almost 2022, late 2022, or somewhere about thereabouts, we were hearing quite a lot about the Chat GPT, the GPT-3 and GPT 3.5 Turbo, and so on and so forth. And when I was playing around with that, even maybe even before that, about 3 years back, it was fun. It was fun from a point of, it was able to generate a lot of responses, but we had to wait for maybe another token to be used. You could only ask only a certain number of questions there, and the responses in some cases were not factually incorrect as well. So it made us laugh about how that was there. But overall, I think it was really great these chatbots were doing at that point in time, right? Now, so that's why I said, I didn't feel that complete magic. Sometimes with Google, you find a lot of the search results are very, very highly accurate. It's a very mature system, but if in perspective, if we think about these LLMs and the chatbots in about 2 or 3 years back, they were still not that very mature. Of course, there was a breakthrough, and we'll come to that breakthrough, but it was not completely magic. Now, what are we talking about in terms of these LLMs, right? So I know a lot of us, we think about AI, we think about the what kind of field it is, where do these LLMs fit, how do these GPTs or the chat GPTs of the world fit in, right? So if you look at it, right, there is artificial intelligence. It's a very broad subject where the idea is to have intelligent machines. Now, if you look at the very bottom here, so that's where the transformers or the GPTs and the generative AIs and all of that actually fit in, because these are all highly they come from a neural network based algorithms and all of that, where the transformers are learning about data in different ways, right? So there's a method through which we look at it, right? This becomes one of the parts of that artificial intelligence realm there. Okay, and how did it evolve, right? So we were talking about what happened there. How did this evolve, right? And is it something which is very recent? If you look at the history of ChatGPT, it came onto the scene in about 2020 or 2020ish, 2021 kind of a time frame, or maybe slightly later as well. 2022. There you go. Sorry, honestly, but the work about the large language models and such kind of chatbots, all of that began way back in 1950s, right? So the earliest chatbot that was created was Eliza back in 1966, and if you do a quick search, you'll also find one of the Eliza chatbots available on the net today, and you can see it acts like a clinical psychologist, and asks you a question in return when you pose a question to it, right? So very limited kind of functionality there when it was built back then. So the research around chatbots, the research around artificial intelligence, all of that has been happening for several decades now, but the actual breakthrough happened around 2017, where a research paper, a white paper by Vaswani and a couple of other of his mates, where they submitted a paper around transformer architecture and all of that. So even though machine learning, deep learning, all of those concepts were in vogue up until 2017, really the transformer architecture around 2017 is what changed this for the large language models. Up until then, there were different efforts that were put in order to build these large language models, and to certain extent, some of the companies, some of the those pursuits were they took fruit, but really the transformer architecture is what changed the whole game for them, right? And pretty soon thereafter, this Simon GPT came out. And then when you see this around 2020 is when the Curial GPT-3 LLM large language model and DALI in 2021 came in. And but the big breakthrough was around the GPT in 2022. And now, since then, there's just an explosion of different kinds of these chat tools, as well as the large language models that has happened on the scene now, right? So it has erupted in a very big fashion since this whole transformer architecture research paper was submitted in 2017, right? So now, what do we mean when we say LLMs and chatbots and all of that, right? So like I said, generative AI is more of a broader term to talk about any kind of content creation, which includes either text or images or video, or even voice and things like that. So different kinds of content that can be created, right? So it talks about a whole lot of different kinds of content generation aspects, of which the large language models, they are based on predominantly text and image data sets, right? They're trained predominantly on text, and they also generate output in terms of either text or images itself most of the time. The one important thing to remember about the LLMs or large language models is they are stateless, meaning stateless applications, meaning that they are if you don't provide an input, there won't be an output for them, right? And they don't have a consciousness of their own. So when we talk about our general or artificial general intelligence, we are expecting machines to be able to tell us, hey, this is the kind of, this is the kind of emotion that you want to have to show. These are the kind of general output that you have to show. For example, if I have to convey my emotions to somebody, right? There is a certain thought process that goes in. There's a certain circumstance in which it happens. There's a certain way in which we think and we generate that emotion. For LLMs, that doesn't happen because there's no consciousness. It only depends on an input and output kind of a process, and they without that consciousness, there's not a whole lot of use to those LLMs. So that's why they're known more as a stateless application. And chatbots are nothing but they're programs that are actually sitting on top of these large language models, these AI and don't get me wrong, there are chatbots which are not AI powered as well, but here in this case I'm specifically referring to AI chatbots and those that actually sit on top of the large language models. Now chatbots have, like I said, they've existed since 1960s or so on and so forth, wherein there was rule-based chatbots or maybe very limited kind of feature functionality that they had, right? But with the large language models, the chatbots have advanced quite a bit, and they are often powered by these LLMs underneath, and not just pre-programmed responses. They can also understand the context in which the user is providing that input and generate response and take specific action. We'll look at that in a minute. So yeah, so the difference there between generative AI and large language models are that LLMs are a type of generative AI, right? And they specifically specialize in language related tasks only, right? Whereas the Gen AI is a much more broader category and has, and can create a variety of content types. So that's where they're the big difference there, right? And there was a question about the training of the LLMs. Yes, so LLMs are trained on large data sets. And in the upcoming slides, we will also see how big some of these data sets can become, right? In the traditional sense, when we talk about machine learning and all of it, the way we used to, or we continue to do that even today with machine learning, is somebody has to be able to provide the data. Somebody has to identify what kind of data input has to go into for the machine to learn, what kind of algorithm that we need to choose. And before that data is passed on to the machine learning for training and scoring and all of it, we also need to identify what kind of features. When I say features, it's not raw data that we can send for training, right? We need to be able to filter out certain types of data from that data set, identify what kind of attributes, what kind of features are really required for the machine to be able to learn, right? And then also define how that outcome or the output should be. Right? What attributes am I expecting? Am I expecting some sort of a classification or scoring or whatever it, right? So the different kinds of. In the case of the generative AI and large language models, if you think of it, right, our experience with the chat GPTs or Gemini or Claude and all of that is, it's very unstructured in the sense that we are entering a lot of data, whatever comes to our mind. I open up chat GPT and I'll say, hey, look, this is, I want to be able to write a story. I want to be able to understand something else, right? So there's a lot of data that's going in. And some of that data depends on how it is structured, but sometimes that data goes and trains the models that are sitting behind. So there is a difference in how the large language models are being trained compared to the traditional machine learning models. There is some commonality in the foundational models that we talk about. The foundational models are the ones on which the LLMs are built. The foundational models, they are trained with some amount of supervised learning, but largely, by and large, the large language models, they fall into a category where we can almost debate that it's unsupervised kind of learning too, right? Because what's happening is, and I'll come to it when we talk about how the large language models are trained. So there is some amount of unsupervised learning as well. Okay. Anyway, so that's a quick update about that. Sorry, the quick introduction there about that. Now, like I mentioned, there was the white paper around transformers, which was submitted by Vaswani, right? So what's a transformer now? A transformer is underlying, so within the large language model, the transformer is a set of neural networks that will consist of different components. Again, you need to, just like you have to encode the data that we are sending to the model. You have to encode it. There is also, once you encode it and store it, that's a way of that's how the LLM understands. You also need another way for it to be able to, for generating the content that you're expecting, to decode and present that on to the user in a certain way. So this transformer is nothing but that whole engine, that core, where that new there's an encoder and decoder and some self-attention capability. We'll talk about that also. We will talk about what those mean, right? But that's at the core. So we will talk about some of these terms, like transformer and all of it. More recently, right, prompt engineering, right? A lot of people have actually, you may have heard about prompt engineering in your conversations, or it's become the cool thing a lot of people have been talking about, right? What is prompt engineering is that when we talk about the large language models and the GPTs, we as a user are typing in some, it can be a statement, it can be a question, it can be some command that we are providing to the model there, right? So that's a prompt. But how does the machine understand that prompt, right? How does the machine understand that, hey, this is what the user is expecting? And how does it generate very relevant response back? So it requires it requires certain amount of engineering before it can be released for public consumption. So that is where the prompt engineering comes in, right? So I'll walk you through with a couple of examples as well as we move forward. But in essence, if I have to quickly say what that is, then it is about crafting prompts that are effective in generating the desired output. With me so far? Any questions? No? Okay. And the other word that we'll also, other term that we will also use is embeddings, right? This is to do with again the how we are passing this data from the prompt, right? We're in the prompt, in the prompt we said write a story, right? How does that write a story, that statement, translate back to the, how does it go to the transformer? How do I get a response back, right? So that's where embeddings actually come into the picture. So it is a term that's used, where the text that we enter, it converts it into a vector format, a vector representation, right? So it creates on a vector scale, it converts that into a number so that the specific text can be searched faster for a classification as well, right? And lastly, it will, we use a probability distribution for again, decoding each of these words which are sitting close by to that particular set of vectors, right? So for example, if I say, how are you? Right? The moment we start typing how and are, the third word, automatically you probably see on your phone, on your keypads, that there is, the suggestions come as how are you or your or something like that, right? So the prediction of what is the next most probable word, it is coming based on how this data is being stored, what's the probability of that particular word coming after how are, so on and so forth, right? Now, the one difference there being, on our keypad, on the phone keypad that we typically look at, there are only about 3 or 4 words which are predicted after every single after whatever we are typing. But in the case of large language models, it's not just 2 or 3 words that we are typing. We are in fact sometimes providing large number of it's an entire paragraph, or maybe sometimes we want to upload a document, we want to be able to write large statements or maybe questions with quite a lot elongated prompt. So how does the LLM understand it and then generate responses? By having these embeddings and passing those embeddings onto the within that transfer model and all of that. So these are all terminologies that you will see surfacing in the upcoming slides, where we will talk about that, right? I know this may be a little technical if some of you have not interacted with an LLM or a gym, but in the simplest way to think about this is, hey, there is a black box model, AI model behind the scene. I'm feeding some data. I'm typing some prompt. The way this model is understanding this or converting the simple user entered data into a format in which it understands, processes it, contextualizes that, and based on its understanding of that particular language, the natural language, then tries to correlate and saying, okay, this is what the user is expecting as an outcome, and then converting or decoding it back. That is what we're talking about here. Okay. All right. So you see how much there is a lot of work that goes on behind this, right? Now, because these models are so sophisticated, so complicated, right? Companies actually see a lot of value in these, right? Now, not only are they able to use or take in as large data as input and generate large data as output as well, they're doing it in really quick time, right? Therefore, one of the things that's happening is there is companies do see a lot of value with these large language models, because what they see is they can get to some of these business outcomes a lot more faster, right? These LLMs can analyze large amounts of data in really fast time. They can process it very quickly. They can generate human-like content, right? If you ask a chat GPT a question, it will respond back in a way that you'll understand very well, right? Once upon a time that was not possible, right? If you remember, or maybe even if you take some of the examples of some of the chatbots that we see on WhatsApp, or if you go to maybe some of the portals like an IRCTC or some, you'll see some chatbots on the right hand corner. Some of them have a very rigid. Sorry, was there a question?
No, sir.
Okay.
Someone has done.
Accidentally unmuted. Okay, fair enough. So sometimes these chatbots become very rigid. They have only specific kinds of responses which they will provide, right? But on the other hand, the large language models, because they're trained on vast amount of data, and when I say vast, I mean literally, for example, OpenAI and OpenAI has and some of the others, they've trained their large language models on pretty much everything that's publicly available on the internet. There's a outcry around that as well. But if you think of it, right, that's how big some of these models are. And so that is where it's able to understand all these relationships between how the languages actually operate. It's not that they understand it, like they don't understand it the way we do, but that embeddings and the vectors that I was talking about, they understand it in that format and then predict how to put it all together. So they're able to generate this human-like content very well. Okay. And not only generation of content, but they're also able to extract the most key phrases from various kinds of content. They're able to extract the key aspects from the data, and then able to summarize that also, or even translate it into other languages too. So there's a lot of benefit of this from these the large language models, or the LLMs there, right? Now imagine if you're a company that's operating in India, you're a Swiggy or a Zomato or whatever it is, right? And you're operating in all over India, right? And hey, hello. I know there are young kids also who are interested in an LLM, but I didn't know that there are such young kids there as well.
Sir, please wait a minute, sir. I will mute all the people.
And it's
1 minute, sir. Sir, you please unmute yourself.
okay. Can you hear me?
Yes, sir.
And are you able to see the slides as well? The full screen?
Yes, sir.
Okay. So where was I? Yeah, okay. Generating human-like content and provide. So the next one is providing intelligent responses, right? Now, because the LLMs are trained on such large data sets, they understand the probability of what that particular context is, and therefore they can provide quite a lot of intelligent responses to many of the queries, right? They're able to it's not exactly the natural language understanding in many cases, but because they're able to connect the dots between how these vectors are stored, which word comes before, which word comes after, or sorry, which vector and all of that, then they're able to put together the response that actually we are anticipating. So there's a lot of processing that happens behind the scenes. And lastly, it allows to save time and resources, right? So if I were, and I'll be honest, I'll be brutally honest here, since the time the likes of all these chat GPTs and Geminis and all of that have come in, there have been times where in my line of work, I need to be able to prepare presentations very, very quickly, right? And then day in and day out. As a product lead for the area, I have to present the vision about the document. So a lot of times I need to refer to I need to refer to different kinds of content or even structure my thought. So what I do is I go and ask these LLMs and the chat GPTs, hey, tell me, or maybe give me an outline of how should I present this? Give me an outline of, how do I write the product requirement documents, right? What are some of the pitfalls of this? Yesterday, when Ms. Priyanka was alluding to, perplexity is one such place where it not only gives you a response, but it also gives you citations, references from where it picked up those kind of responses, making it a lot more trustworthy. One thing which the LLMs don't do, and something that which you all have to bear in mind is there is when we talk about the traditional AI, there is explainability that is inbuilt, or we can build out explainability with these machine learning models. And when we say explainability, for those of you who are not very familiar with AIML, is how do we explain the outcomes of the machine learning or the AI models that we have used? What were the attributes, or what were the variables that actually led to certain outcomes? Why does the machine learning model score a particular attribute higher, something lower, and so on and so on. So that explanation is what allows us to build trust in the model, right? So we need that explainability of various kinds of attributes and all of that. So with LLMs, it's a black box. And it's a generative model, right? It's not something which can be easily explained. So how do we do that? So a lot of times there is question of trust, which keeps coming up with LLMs. Therefore, it's important to understand, how do I know that, the LLM has actually given me the right response? I'll in fact quote a real example that happened with me, a real experience, right? As Dr. Saijyoti mentioned in the beginning, I'm a music aficionado. I listen to music every single day, right? And different kinds of music. And Ilayaraja has had a huge influence on me. Rahman has had a huge influence on me. So I listen to their music quite a bit. So there's one time where I heard a song which felt like, it was an Ilayaraja composition. So I took that name of the song and I asked ChatGPT, hey, this seems like a beautiful song. Who was the music composer for it, and what were the top music compositions of this composer? Guess what it did? It said it gave me the right answer that that song was composed by Ilayaraja Garu. But in the subsequent part of the response, where it said, here are some of the other popular songs by Ilayaraja Garu, there were at least 2 or 3 songs that were A.R. Rahman's compositions. Okay, so it's not that it is actually doing a fact check of the responses itself, but because the way it is trained behind the scenes with all this context, so there could have been some contextualization of how or what it was trained on, what kind of data set it was trained on. So it was generating factually incorrect answers, right? So do I trust the responses that the LLM gives me? Do I trust the output that the LLM gives? We don't know, right? So therefore, that explainability with the traditional ML models and all of it, while it is not there, the kind of perplexity, and some of the other newer LLM the models that are coming up, where they provide citations, reference to saying, hey, here is where I picked up this data. I think that is the way they're trying to build that confidence with the end users to say, I want to be able to build trust, right? So not just the value there, but also the value is increasing because these LLMs are increasingly becoming very smarter and smarter with explainability and all of these things, right? So that's why companies see a lot of value in this, because given these benefits, now they can go and address a lot of business use cases, right? Imagine if every single company on earth was able to bring in a lot of data, and don't get me wrong, and if you look at the way data has been exploding over the last few years, right? Every single touch point that we have, people are collecting cookies. When you go online, cookies are being collected, so there is data available there. When you browse something, that data is being collected. When you go open an app on your smartphone, data is being collected. There's a lot of exchange of data that's happening. So there's access to so much data and so many different data sets that it's possible to train these kinds or tune these kinds of LLMs and generate, understand the users and the user behavior and different kinds of language and so on and so on. So there is quite a lot of data that's coming in. So companies want to be able to tap into that data and then pass it to these LLMs so that they can build out specific use cases and personalize a lot of it, right? So that's where the competitive advantage, cost saving, personalization, being more efficient and scaling, all of these come in with LLMs. Okay. Now, a question to think for all of us, and this is more of a question that I wanted to pose to you. Do you think businesses have already derived value from LLMs already? Would anybody want to take a stab at it and maybe either put it in the chat or maybe just say verbally? What do you think? Was my question clear? Do you think have businesses?
Can you just repeat?
Yeah, I'm asking you. So I talked about the strategic value that LLMs bring. Now, do you think businesses across the world, have they already derived value from the large language models?
Definitely. In case of developers and everything, right? As you know, the ChatGPT gives the LLMs and all that. They are generating the code fixes and all that. In that case, the developers' point of view, it is decreasing. Business value is decreasing. Whereas in case of SRT professors, right? We want to make a paper. First, we need to use 4 days. Now we can just generate in couple of hours with some modifications. So yeah, has some divided value in that case. It is just one business case I have discussed, but there are so many as well.
I know. Hey, thanks so much, Rakshita, for that insight. Appreciate it, and I agree with you
Yes,
to a
sir.
certain extent, right? And Dr. Kranti Kumar also has put it in the chat that, yes, there is. The only caveat that I'll put there is businesses are continuing to derive value out of LLMs, and that journey has just started. Meaning that, yes, Akshita, to your point, that there is a lot more efficiency which several users, and not just developers, and not just developers or some of the businesses have derived, but there are a host of different kinds of personas. Let me call them personas, because it can be developers, it can be QA folks, it can be product folks, it can be leaders in the organization, academic interest people, healthcare people. There's several people who are actually deriving benefits from using the chatbots and LLMs. But at the same time, we are only scratching the surface at this point of time. Okay, I'll tell you why. Is because what is happening is that this whole journey, like I said, around the LLMs and all of that started only about 2-3 years ago. We are still in the beginning phase where prompt engineering and maybe some amount of RAG-based use cases, and I'll explain what RAG is also in a few minutes. But RAG-based use cases are coming in, right? But there's a lot of business value that is yet to be derived from these. Plus, also, when we talk about external use cases where we have to think about, okay, the LLMs are here, they're pretty large models. And yesterday, Dr. Reddy, the principal, and Dr. Kalavati and others were talking about, the computational costs of these LLMs, right? They were saying it's quite high because they're being trained on a lot of data sets. There are not CPUs, GPUs that are being used for all of the training, right? There's a huge cost of maintaining and setting up all of this infrastructure. So that cost has not yet been completely recovered. So if you look at, let's say, go to a chat, the Chat GPT or Gemini or Microsoft Copilot or whatever it is, you'll see that they will provide you some credits, and these credits, once they expire, you'll have to purchase it. They are trying to monetize that whole ecosystem by saying, okay, whoever wants to use or make a call to the LLM, we will monetize from them. That's how they're able to fund some of these, right? So from that perspective, the businesses have not yet derived complete value out of these LLMs. Okay, and there is still a long way to go when it comes to lowering the cost of computing and all of that. Okay, that's that. Now, how do LLMs work? Does anybody recognize this person? That's a still from the movie Robo or Robo 2, Endiran in Tamil. So in that, he's presented with this. It reminds me of that. It reminds me that he's presented with a book, and he just flips the book, and that's it. He says, "Done. I've read it." LLMs are almost like that. They are able to process so much data and train on that in really quick time that it makes it such a viable thing for us to look at. I'll share this, or you can watch that clip later as well. But I found it very funny because the speed at which they show it, that he reads that book in the movie, that is approximately the kind of the speed that some of these LLMs exhibit today. They're able to learn and be able to predict quite a lot of generate responses. Okay, stay with me. Here is where it gets a little technical, and this is what I was talking about. Now, to earlier question about understanding the training, how the LLMs work, all of that. This is the key part. We were talking about the transformer as a terminology. So what you see here, this is the transformer. It's a simple transformer. Now, those of you who are probably have learned about transformers or have seen, read about this space, this is a very basic diagram here. There can be variations of it. And depending on what kind of LLM people use or the different companies are actually building, you could have variations of these transformers also, right? Now, I will talk about it, but most simple thing that I want you to look at is, look at this right side. Right? There is a prompt. Example is summarize the text of so and so, or maybe the prompt can be provide a poem in this particular style, or generate a list of keywords which are based on a certain parameter or some keyword there, right? That input is sent to the large language model, and the large language model is able to understand that and then generate an output. It can be text, it can be code, it can be some automation workflow, whatever it might be, right, that we're asking. And all of that processing is happening here inside this transformer here, right? Now, I know it is a little too small. These fonts are a little too small here, but I'll read it out for you. So there is an input embedding here. And remember, we were talking about the terminology embedding earlier. There is a positional encoding. Then there's a multi-headed attention here. And on this side, you see there is softmax. There's a feed forward. Again, you see multi-headed attention and the output probabilities, right? So these are all they're on the outcome side of it. So let's get into that, right? Okay, this is a much simpler diagram that you can find. So look at some of these terms. Those of you who are making notes, you can also maybe just write down, or you can look them up later. But tokenization, input embedding, position embedding, encoder, decoder, attention feed forward, these are all the key aspects of the transformer. So for example, I was telling you that, you know, if we typed in how are you doing and with a question mark, now the LLM does not understand this as a sentence. It breaks it down into you know, vectors, and these can be broken down as vectors, or each word can be a vector, or sometimes when there are large words, it can even break it down into maybe smaller parts. It can chunk it. It can break it down into characters as well. Some of them, depending on how that breaking is happening, you can break it up into, you know, this. And these are called tokens. Now these tokens are then sent as embeddings. You know, these embeddings are essentially, you know, what's happening is that you will break these complex text or this particular line of text into every word or prefix or whatever it is, and store it in a way that, you know, there is a certain vector notation here, right? Or some positioning, specific position to identify where it is. This allows for searching and classifying these tokens later on, right? Okay, so let's go into each of these in a little more detail, right? So we were talking about tokenization. So for example, if we say write a story, write is one token, A is one token, story is one token, and this punctuation mark, this full stop or period, this also becomes a token, right? So it will break this down into every single word or prefix or suffix or whatever it is, and send them to a token from the library. That's what it is, right? It's the most basic step. And then comes the embedding part. Now, when we say embedding, this is where the vector embedding is happening. It converts it into a numerical format, and this is for better search and classifying of each of these tokens. One word of caution here: these embeddings are unique to that particular large language model only. So if you're working, let's say, with OpenAI's OpenAI's LLM, then the embeddings, you have to use the embeddings that have been used with that particular LLM only. You cannot take the embeddings, because these are all stored in a vector format. You cannot use these and go and play with use these embeddings for a Cohere LLM, or you cannot use these for Gemini or Gemma or whatever it is, right? So each embedding, these embeddings are tied with that particular thing. So this is how that particular LLM is actually that's being stored. Okay, so we've broken the entire content into tokens. Then each of those tokens have been provided a numerical value for classifying them into a certain way, right? And then once that has happened, right, now comes the piece about, I don't know grammar, right? I mean, the LLM doesn't understand grammar or language or whatever it is. That I don't know what is a verb or a noun or any other syntax. All it understands is what was the relative position of where that particular word or that particular token appeared, right? So if I said write a story, full stop, then write was the very first word. It was followed by a, then story, and then. So it will store the positional encoding as 1, 2, 3, 4. So next time there is another statement or another sentence that comes in, it will automatically use a different positional encoding. For example, if I, instead of saying write a story, I said a story was written, then a is the first one. So the position of that a is at number 1. Story then has a positional encoding of 2. Was is a new word, that's a new token that will be entered. And instead of write, now there is a new word called written. It doesn't understand whether it's past tense or present tense or anything like that. So that positional encoding will change. But now, given that it'll keep adding each of these like that, right? So when I said that, it's the LLMs are being trained on the vast amount of data that's publicly available on the internet, imagine number of positional encodings, number of tokens it would have created, it would have stored, right? It's a huge task that way. But then it will generate these it'll generate the probability distribution after this to say, how does this how do I see what is the most probable word or most probable punctuation or whatever a token after this, right? So that's how it tries to understand, right? So yeah, it's positional encoding consists of adding a sequence of predefined vectors to the embedding vector, and it ensures that we get a unique vector for every sentence, and sentences with the same words in different order will be assigned different vectors. Okay. So now that that's been done, this is now going into the transformer, right? So the transformer, there are 2 components. Like I said, there's an attention component and there's a feed forward component. The attention component, and this concept came in recently, the self-attention is another related concept to it. So the attention component, it's a useful technique that helps language models understand the context. So for example, if I said there is money in the bank is a financial institution, right? But if I also said bank of the river, on the river banks, something like that, that's a different kind of a bank. It's a land which is right next to a river. How does the LLM understand that? It understands based on the context in which it is being used. So it will associate money and bank. So it will understand, or it will correlate to say, okay, this is a bank which is associated with money. Money has a certain vector. This is what it is. So it will associate the two. So you will see usage of bank in that particular format with money in upcoming usages, wherever it generates the responses and all of it, right? And then feed forward component will transform the output of this into the final output of the model. So this association, so now at this point where the input is going to the attention, it is still confused. It will say, okay, should I use it as a land mass bank or should I use it as a financial institution? But after that attention and that context training has happened, it will say, okay, this is related to the money here, okay? And that feed forward will go. I know this can be a little more tricky for those who have not been very close to this, but I still wanted to talk about it because there are people who may be interested in this particular area of research and understand what transformer what it is. And I'll also share the or maybe if you can look it up as well. Read the white paper by Vaswani et al. On the transformers, right? You'll find it easily. If not, just ping me. I can share that link too. Now, okay, coming back to that. Now that the context has been set with respect to how each of these vectors and each of these phrases has been used, now what do we need to do? The output is also defined here with respect to that particular context output. I need to understand, given that when the user says write a story, I have sent it to the transformer, embeddings, tokenization, attention, and the feed forward is complete. Now I need a function to say, what is the most probable word or most probable sentence that I should start with? So every time when we say tell a story or write a story, my habit is I start with once upon a time, right? Or most of us do that, is it not? So the most probable word that it will identify is, oh, once. because it has been, assuming that this has been trained on a large data set, it'll identify that once is the most probable word. So this becomes the first word here. And see, the softmax function, that is the job of the softmax function is it turns these into the probability score for all the outputs and says, okay, once has the most probable. Somewhere or there once was a king, somewhere in a faraway land. So these are all different kinds of words with which a story begins. But the most probable one with which a story is written is once. So it will throw an output saying once is the most probable one. So if going back one more time, there's first somebody is sending a user request that was broken down into multiple tokens, right? That was converted into a numerical format, embeddings. And based on that numerical format, a position encoding is also assigned to it, which says where in the sentence did it occur, right? It generates that positional value. And once that is done, it also associates some context to it and then says, okay, this is the context in which this particular word was used. And then you build out the probability of based on this context, what are the probable values or what are the probable words that this LLM should generate now, so that the users can see a coherent response. Okay. And then last time, now this is only one particular word, but how does the LLM learn all of that, right? Now the transformer is trained on maybe just it's not just one sentence, right? It's trained on the entire internet. But how do I test my large language model as to whether it will generate the right response or not? We have to be able to test it out, and that's where we after the training is complete, then there is a lot of question and respective answers are provided so that the large language model can adjust and tune its own responses there, right? So these transformers also have bias, and we'll talk about a little more of the bias also in some time. But they can also be biased. They can generate biased responses because we are dealing with probability distribution. If the internet has more of certain types of statements and certain types of sentences, likelihood of that those kinds of statements or those kind of responses being generated is high. So there will be there is a possibility that there is bias towards all these things that the transformer has learned, right? So post that training, it also is important that we tell the transformer that, hey, here are some possible question and answer. So if we say, for example, what's the capital of India? How will it know that it's not learning based on a question answer? It's not a general knowledge quiz, right? It is learning based on vector based notations and embeddings and all of it. It's only an understanding in the context. So if we tell and tune that the transformer and say, hey, that capital of India is New Delhi, that's when the some amount of, like in the machine learning world, we call reinforcement happens. We are reinforcing that, hey, this is the right answer. So it will understand that and then adjust some of the responses. So that way, for the large language models also, a lot of questions and answers are provided. Sorry, there's some background noise there. Okay, right. And so that is how the LLM are trained with a lot of publicly available data from the internet, and for subsequently a lot of questions and their respective answers there, right? And yeah, see, here are a couple of other examples. Not just question and answer. We can train, or we can fine tune, we can reinforce some of the responses based on conversations, articles, documents, whatever it is, so that it can perform a certain set of outcomes. It can generate a certain kinds of outcomes based on the kind of the conversations that we are the content that we are able to train it on. Okay. Dr. Saijati, did I answer your question how the LLMs are trained, what are happening there? I'll come to the billions of parameters, all of that in a minute. And that billions of parameters and how many billions of parameters for which data, which LLM will that also will cover it in one or in a couple of slides later. and what are the challenges in transformation of data in LLMs? When you say, I didn't quite get the question, ma'am, but maybe I can take that offline as well. We'll do that. Okay.
Okay.
And also, now I'll talk about some model parameters. Okay. This may sound alien to a few folks, but please bear with me. Think of the large language models as it's a library, right? It's a huge library. You've got pretty much every single book in the library. It has read it. Every single encyclopedia, dictionary, everything, right? Now, if I ask a question, the LLM does not have a context in what kind of question, in what circumstance, what reference point are they asking this. It'll only, because it's a end of the day, it's more of a model. It's going to figure out what that probability is and give me some answer. But we also need to tell the model that, I want the responses in a certain range, or I don't want you to get too creative and give me some wild answer and all of it. And that can happen, right? So we need to put some certain parameters in place. In the machine learning parlance, we call these parameters, hyperparameters, all of that. But we also need to, in the LLM space also, we use something similar, right? Tokens we already talked about. And depending on the model, here I'm just mentioned a range of 1 to 4,000, but there are different kinds of models that allow for different number of tokens that they can work with. Some of them allow for up to 16,000, some with 2,000 tokens, some can go up to 32 and beyond 32,000 and more as well, right? So we'll look at that. Temperature. Now, the randomness in the output, this controls the randomness in the output. Say, for example, if we say that, hey, how do you make, is it cold today, right? If it is, I ask a question, is it cold today? It has no context at all. It can probably just throw back a sentence very, very irrelevant to that particular, because it doesn't know in what context we are asking that. So there can be a very random thing saying that cold and cough can happen to kids if it is very random, right? But I'm asking about weather. So depends on how do we control that. So if we are able to set in the probability distribution or the normal curve, closer we are to the bell curve at the center, the lesser the randomness in the outcomes, right? So that's where from 0, if we say 0 is at the center of that bell curve, to all the way to the 1, like in the bell curve, the randomness keeps increasing. So what we're saying is that depending on what words or what tokens are coming in, it'll consistently find the same kind of words in that small area under the curve, in the bell curve, right? But if we increase that area under the curve and the bell curve, right, there is a possibility that it may pick different kinds of words which appear before and after the specific, the words that were there in the input. So that randomness can either decrease or increase depending on how we set that temperature there, right? Then top P, top K are two different parameters. Top P talks about cumulative probability method for selecting the next token. We can again set it saying, I want it in a range of 0 and 1 to keep that control what kind of top tokens I want to look at, right? And similarly, top K will look at the sampling method, right? If we are asking for a higher, if you're setting that at a higher K, 500 or close to 500, then there'll be more randomness in the sampling that is happening, where the model chooses the next token. Randomly, it'll choose a token and then suggest that. So we want to be able to control, depends on the use case. These values may be changed based on trial and error. In fact, when we started out with some of the use cases to implement, even for some of the most simplest use cases, we had to do a lot of trial and error to see what is the level of randomness, what are the kinds of words and tokens we want to actually see in the output, and what kind of randomness do we want to do in the sampling of the data. We had to do a lot of that trial and error to begin with. So imagine now when we're training the models with all these, there could be a lot of variations depending on how it is intended to be used. Okay. Then frequency penalty. Penalizing, let's say, frequent token. If there is a certain style in which we write, right? Everybody has a certain style. Some person may say, somebody may say, then, so frequently we use certain words. Similarly, LLMs also have this habit of using frequent words and all of that, depending on the probability. Now, if they use a lot of these frequent tokens, then there is a way to penalize that also, to reduce that repetition, encourage a lot more creativity, some random outputs and all of that, so that we are providing users with different kinds of variations of responses there. Right? Likelihood, the probability of token following the current token ranges from -15 to 0. It's highly unlikely, which is likelihood of that token occurring, or to 0. And last,
Sir, you are on
Sorry.
mute, sir. Please
Sir, do
unmute
you
yourself.
want to take any break, sir?
we can do it after this particular slide, ma'am. Sorry, I didn't realize that my mic got muted.
Okay.
Where did you lose me, ma'am?
Here itself.
Oh, here it is. Okay. So likelihood and then preamble. Preamble is, for example, I need to set some context, initial context of how what is the guiding message. For example, if I say that I, as a speaker or a presenter for an academic session like this, where it's for an FDP, faculty development program, I want to be able to do this, right? So there is a context of what kind of a persona I am. I'm a speaker or a presenter, right? What kind of a session it is. It's more maybe a lecture series, or it's a conference, or it's an event, or whatever. So there is some context that is being provided. Based on that context, if I say, help me understand or help me craft some outline for presentation for this, then it understands, okay, you want to do something for that, right? So that preamble allows the LLM to understand that context, and based on that, it will try to look for certain patterns and say, okay, in this given kind of context, here are the kinds of outcomes. Or if I say, I'm a marketer, I want to reach out to a certain audience, help me craft a segment, then it will do that. Or so on and so forth. So like that, a preamble helps to set the context for the LLM to provide very specific kind of responses in that particular context, right? Now, a little more about how this can be trained, right? There are available a lot of pre-trained LLMs that are available. We can use them as is, right? Or we can improve the LLMs by using better prompting. We can take an existing LLM, an OpenAI ChatGPT, the GPT 3.5 Turbo, GPT-4, or Gemini, or Cohere Command R, or Claude from Anthropic, Mistral, whatever it is, right? We can add additional prompting techniques or an additional prompt on top of them to be able to get much more accurate results, or depending on the industry or the use case. So if I wanted to do, let's say, expense reporting summarization, right? A lot of times in organizations, that's a very common use case. If I want to do expense reporting summarization, I can craft the prompt in such a way that it can understand the context in which it is happening. So it will tailor that results very, very specific to the expense reporting. There are ways in which the prompting can be used, zero shot technique or a few shot technique, so that we can train the LLM to say, zero shot meaning I'll directly say the prompt that, hey, create this expense reporting summarization kind of without any examples. Few shot meaning I will set up some examples and say, hey, here is how an expense reporting was generated, summarize this for me. I'll give 2-3 different examples so that the LLM is able to understand the context in which the expense reporting is happening. So like that, depending on the use case and depending on the training technique, we can pretty much fine tune the model's focus and get far more accurate results, right? Now, sequential prompting. We can set a sequence of prompting saying one after the other, so that we are building context, saying you are you are a marketer, or you are a HR person, you are a professor, you're an academic person, you are a minister, whatever it can be, right? So, and then based on that, after that, we say you're trying to do this, you're trying to build a lecture series for this. You want to be able to craft some contextual, study material for it. I want to have some questions for it. I want to have maybe an exam based on this. Whatever, you're providing some context, a series of context that allows the LLM to understand how you are, what exactly you're trying to accomplish. So that way we can fine tune and train the LLM even further. Retrieval augmented generation. I'll spend maybe 1 or 2 minutes, ma'am. After this particular slide, we can probably take a break. Right. So retrieval augmented generation. If every organization, for example, or every institution used same ChatGPT or 4 or Claude, whatever it is, right? The results will be very, very similar after a certain point of time, because they're all being trained on the same kind of thing, and there is not a whole lot of differentiation. But if I was, and I, like you saw, for example, at the beginning, very beginning, when the introductory slide was put up, there was a certain theme, right? There's an orange colored background, Vvit brand logo. There's a certain font coloring and all of that on the presentation slide. So there is a certain way in which the branding is being done, right? Now, similarly, when you take or think about the language that is used, each institution has a certain way in which they use the language. They have their own tone, format in which they do it, right? Similarly, they may have a specific data set on which they want to generate some outcomes to. Here is where retrieval augmented generation can come in handy, because while LLMs will generate very generic response, you can, along with that knowledge, or that LLM's knowledge, you can combine very specific organizational knowledge or specific data set or a specific focused data that you can pass to the RAI, this retrieval augmented generation framework, and get highly contextualized responses back from the LLM, so that you can say, I want a Vvit branded image. You'll get it, because you have provided that specific data set there. Or I want to have a brand tone for my emails. You'll get that particular tone of the in the emails. So there are a lot of such use cases which are coming. Companies want to make the outcomes of LLMs very, very specific. There are several use cases that are going to come on RAG. Next is agentic, where agents are just like, you can think of them as microservices or agents which will perform specific tasks for you. These agents can actually go perform some task and say, okay, the LLM response was not satisfactory. I'm going to look for a different response. I'm going to maybe search this particular resource. I'm going to do some other task. So you can set up agents to perform additional tasks on these LLMs, so that you can get highly contextualized responses. Now, when a combination of RAG plus agent happens, these are going to be the next set of flavor, because we are currently in the market today. We are already there at these 3 ways of training. These are already there. We are already there with the RAG implemented solutions too for some of the use cases. But the next big step is going to be around RAG plus agentic, right? Now, chain of reasoning and vector embeddings, we are slightly further away from that. There's still research going on, to my knowledge. I may be wrong as well, but there is a chain of reasoning and vector embeddings based semantic search based training also that can happen. Where chain of reasoning allows it guides the model to break down the complex tasks into a logical reason to improve its own decision making there. Say, okay, because this happened, there's a sequence of that steps that is there. It builds out context based on that logical steps, and then allows the LLM to generate highly focused responses. And lastly, the vector embeddings and semantic search. This is highly granular, by very, very complex. This we are still not explored this, but this is also going to come in pretty quickly. All right, so we can take maybe a quick pause here. When we come back, we will talk about we said all so far we talked about LLMs, but again, There are different types of LLMs, and you can also see some proprietary open source LLMs and all of that. So there's plenty more to look at LLMs and the chatbots there. Ma'am, shall we take a 5-minute break?